Okay, pre-cal, this is your video about writing piecewise defined equations for graphs. Hopefully this will just be one video. I don't want it to be too terribly long, so we'll see how we go. All right, so anyway, we are looking at this graph right here. So if you'll notice, there are two pieces to the graph. So if you can define pretty quickly what kind of graphs you're dealing with, then you can just take the parent and switch them around to what matches the graph. It's not really too terrible. So let's look at this. We have first this graph right here, and as you probably notice, it's just the square root function, but of course it's not the parent function because it's been reflected and switched around. So let's look at the fact that this would be the parent, right? So if you'll notice what's happened here, it has moved to the left 3, and then it has reflected over the y-axis. So what would that look like? Well, it would look just like this. And I'm going to use a brace here because I've got more than one function in here. So this would be the square root of negative x plus 3. That's exactly what we would do for that. But it is restricted, so let me erase what I've got here so we can see how it's restricted. Now, if it was only restricted from here all the way to negative infinity, this would be all the way to the edge of the graph. But it is not. That means it's restricted between the x value for 3 and the x value for negative 6. So I am going to write it just like that. X is less than or equal to 3 and greater than or equal to negative 6. That is how we're going to write that. Okay, so let's look at the other equation here, the other graph. Well, clearly this is a straight line. So it would be going through y equals negative 3, but it is restricted. So what I'm going to do is f of x equals negative 3, that is the graph, but it's restricted. And it is restricted from positive 3 to positive infinity. Notice it goes completely off the graph. That implies forever. So x is just greater than positive 3. And I'm using greater than because it's an open circle. It doesn't include it. All right, so that's not too terrible. All right, so let's look at the domain then. So since this value for this graph stops at negative 6, we are stopping at negative 6. We have no more values to the left of that. We just have values in the positive direction. So this graph crosses every value from negative 6 all the way to 3, and then it includes 3, so it doesn't matter that there's an open circle here. And then it down here it jumps and goes all the way to positive infinity. So there you go. As long as one of your values is covered by one of your graphs, it doesn't matter if it is in the other one. This is what I mean by that. See, that's x equals 3 right there. The square root graph covers that, so it doesn't matter that there's an open circle on the other graph. Okay, so our range. Well, let's look at our range values. This graph down here, or this line down here, covers 3, but there aren't any values down here. So that means that my range includes negative 3, and this is going to look a little weird to you. We're going to close that because it covers negative 3, but then it doesn't cover anything in between negative 3 and 0. So then this is going to be a union, and then it is going to go up to 3. Oh, why did I write a negative? Bad teacher. There we go. Okay, so why did I stop with 3? Well, all you're doing is reading the graph. So look at what I'm talking about. See, we start at y is 0, and it goes up to y is 3. That's how we get that. Okay, so relative min and max. We're not going to actually talk about relative min and max for piecewise. It gets a little too convoluted. So we're going to leave that out. Zeros for, this is where you cross the x-axis. So we're just going to have that one right there. So that's going to be at 3, 0. And then increasing, this graph does not increase from left to right anywhere, so does not exist. It decreases from -6 to 3. So -6 to 3. And remember, I just use parentheses for decreasing values because I'm not talking about values that are included in the graph. I'm just talking about behavior between two numbers. All right, and where does it remain constant? It remains constant from 3 to positive infinity. Now remember, when I'm talking about decreasing, increasing, and constant, I always refer to the x-axis. So I'm just looking at this right here, right and left. Okay, let's look at our next example. We need to switch colors and make this more fun. All right, so we've got more than 2 going on here. So if you will look at this example, I've got this right here, and I've got this right here. Now there's a couple of different ways you could do this. You could easily use 2 lines here, or you could recognize it for what it is, and that is the absolute value function. Okay, and then this is my parabola right here. So obviously these aren't the parent graphs, and I need to figure out, oh man, my writing is not great today. Okay, so what happened to my absolute value graph? Well, normally it goes right here, and so it has moved left 1 and down 4, and the width hasn't changed because the slope is -1 on this side and +1 over here. So that means that inside my absolute value bars, I've got x plus 1, that's left 1, and then -4. And of course, I'm restricted here. Notice that my graph stops right here, and that's where x is -7. And then it also stops right here where x is +1. So x is x is less than or equal to 1 and greater than or equal to -7. That's what my restriction would look like. Okay, now I'm going to use another color for my next graph because we need to make a distinction here and it might confuse you a little bit. Okay, so we're looking at our parabola. The width has not changed, but we have moved right 3 and we have moved down 6. So that means that my equation would look like this. So that's right 3 and down 6. Okay, remember when we were evaluating piecewise functions, we had to pick which one a certain value fell in. So since I included 1 in my absolute value equation, it has to stay with this graph. It can't be included in my parabola. So when I write my restriction for my parabola, notice I have an open circle at x equals 5. So x is less than 5 and it's greater than 1. Now, a common question I get, well, Miss Griggs, could I have made this x greater than or equal to 1 and then made this one up here less than 1? Absolutely. Doesn't matter which way you do it. You just can't include the 1 in both of the restrictions. That's the only rule. Okay, so just be careful with that. All right, so let's fill out our information here. So for my domain, it doesn't go lower than -7 to the right or to the left, and to the right it doesn't go past 5. So it includes -7, but there's an open circle at 5, so that's my domain right there. My range starts down here at -6, and it covers everything up to +2. So it is going to look like this. There's my range. Okay, our zeros. Where does my graph cross the x-axis? Well, it crosses right there at -5. So my 0 is at -5, 0. That's why they're called zeros. Okay. Increasing from left to right. Let's switch colors. All right, so as I look at this, as I'm reading the graph from left to right, see this is decreasing and then increasing, decreasing, increasing. So I'm increasing from x is -1 to +1. And again, at x equals 3 all the way to 5. Remember, increasing, decreasing, and constant, you always use the x-axis. Okay, let's get rid of some of that. Okay, next thing, we're going to look at decreasing. Well, I already said it decreased from here to here. Well, x is -1 right here, so from -7 to -1, it decreased, and then it's decreasing again from +1 to 3. And it's not remaining constant anywhere. Okay, we're going to split this up into 2 videos because those examples took a little longer than I thought they would. So we'll do examples 3 and 4 on the next video.